Welcome to the channel. We have another case diagnostic here for 2005 Honda Civic Hybrid checking light on. So we're gonna dig deep into this. We're gonna do this diagnostic the way how we will do it on the field, fast and accurate. At the end of the video, I'm gonna show you some tips and tricks are behind what we apply on the field, how much theory is behind it.
KAZU thanks the business community for their support during this time of social Pacific Grove, Monterey.
So we have the list of diagnostic code here. So let me go fault report, and we have those. Manufacturer code 65-02 equal to generic code P0141 heater auto sensor heater circuit malfunction. And we have also P1130 heater auto sensor 2 and 3 performance. So the computer is comparing those two sensors and it is saying there is a problem in between those two when it is comparing those. 111-01, that's the manufacturer code. Okay, so those are repetition of the codes. Heater auto sensor malfunction. Okay, good enough. Let's go to data. System selection. Yeah, I went all the way back, but we should be checking only that computer only right now, and we're gonna find out about the data related to heater auto sensor. We're only going to be selecting whatever is related to all the auto sensors pretty much. Okay, check that one, select that one. Well, as we can see, this vehicle has 3 heater auto sensor 1, 2, 3. So that has like a bias voltage right there, 3.8 volts. The air filtration sensor, we have it on negative 128 milliamps. Remember, those sensor works based on milliamps. Air free radio, that's default, key off. The vehicle is not running, we know that. That one is off, that one is off, that one is off. So let's start the vehicle and figure out what happened. All the data related, only we have 2 auto sensors only. Now we're going to start the vehicle and we're going to be paying attention on these 3, the heater. Okay. Let's start the vehicle and find out. Okay, now let's look at this one. So this one is off, this one is off, this one is off. Let's start the vehicle. All of them should go on. Look at the RPMs. All of them are on. 3. Look at that. Boom. That one went off. And look at that one. Because this sensor, the heater circuit is off. See the voltage? 3.8. Still haven't come back to life. While this one now is fluctuating, because it has the heater. So this one is normal, the air fuel radio sensor. The air fuel is about 14.7, so that's great. Okay, so that one haven't come back to life yet. Okay, let's focus on that circuit, the heater circuit 2, because that's the code we have. Let's start doing the testing. In this case, what I'm gonna do is checking for signal from the computer, and also the power from one of those should have constant power with a key on, one of those 2 blacks, and the other one should be the one the computer should be pulsing or should be applying on. So I am across those two, and I'm gonna bring that one to inside of the vehicle, and we're going to watch here the multimeter. Okay, let me start the vehicle. Okay, the computer supplies the voltage. We complete the circuit, everything is good. Uh-oh, the computer released the ground. Why the computer released the ground? So now this means our problem is the computer. That's the reason why we have the coil, because the computer is not commanding. Okay. Wait, there is another test we can do. Let me substitute the load. We're gonna find out what's wrong with this. Apparently the computer is turning off right now. The heater comes on and then turn it off. Why does it turn it off? Why does the computer doesn't like? Is that because the check engine light is on? But why it applies voltage and release it? Go to the next step. Okay, so this is what we know already. So the computer only command the heater to come on for a few seconds, and then it removes the ground. Why? Okay, so normally I like to simulate that one with this test light, homemade, knowing the Ohm's law. This one draw about 1.5 amps. Okay, the most actuator draw like about 1 amp, something like that. So, but in this case, I don't want to use that one because I don't know if the circuit is protecting from overloading or from open circuit or high resistance. So I don't want to add another one and load it out the transistor in the computer with more. Okay, we're gonna get this one. This one only draws 300 milliamps. Let me start the vehicle and look at this here. Okay, so it seems like voltage is there. Boom, computer remove it. Let's plug this one in. Okay, I'll have this one here, plug it in, plug it in, and nothing happened. It doesn't illuminate. Leave it here on top, so nothing happened, so the light does not illuminate. Okay, let's cycle the key and figure out what happened. So we know at the very beginning the computer activates and then release it. Okay, right there at the very moment when the vehicle starts, this one is here. Okay, realize something now already? The computer has not removed the ground. See, computer keeps powering up. See, it keeps powering up. So how about if I remove this one? What will happen if I remove one of these? I remove one of these. Boom. Okay, we substitute the load. So our problem is the sensor. Let's figure out more and dig more into the sensor and find out why. What's wrong with the sensor? Okay, so we know the computer is doing its job. The sensor is getting power and it's getting ground, but the computer is shutting down the system for some reason. Why? Okay, gonna find out that one next. Well, now we know there is an issue on the heater O2 sensor number 2. We're going to go key on. We're going to do a quick checks, very quick checks, but effective. So the first thing, with the key on, I will connect one end of the multimeter to battery negative, and let me see if the power is coming in to. I am connected right here. Let me show you that one. I am connected right there on the 2 black wires. Let me see if I can show you that one here. Right there. See? 2 black. So I'm expecting voltage coming in and voltage going out if the integrity of the resistance is good. Okay, let me plug in that one, and we have 12.07. Go to the other one. You see I'm disconnected right now. Right there. I'm connected, and well, we have good voltage coming in and going out. So that means the integrity of the coil is good. So what's next? Resistance. Let me do a resistance check. Go key off, and we're gonna do a resistance check. Let me go here. I'm gonna disconnect here, but let me go off first, so the system doesn't have to be running. Okay, key off. Okay, so now I'm going to check for resistance. You plug that one in here. Okay, so we're connected through right there. And let me go here to the scale of resistance. Okay, you can see here I am on resistance, and we have 2.4 2500 ohms, 2.5 kilo ohms. Okay, do the math. Ohm's law. How much? 12 volts, how many amps they can push through the high resistance, very high resistance. So this is going to be damaged, but we're gonna do something just to make sure, let me unplug it. Okay, I will go with my other hand, unplug it, and see if something changed, just in case we have resistance in the computer. Okay, look there. Have it unplugged. What we have here. Same. We'll plug it in. Okay. Are we done? No. Let's test the computer control. We're gonna see if the computer is capable of controlling this. Okay, that's the next step. Okay, we're gonna start here. We have a diagnostic trouble code for the heater auto sensor number 2. Right here. You see the code? We have heater malfunction. The manufacturer is giving us here kind of diagram. ECM, sensor. The sensor has two portions. The sensor portion and the heater portion. So 2 wire for the heater sensor and 2 wire for the heater portion. So the heater portion has, with the ignition switch on, pass-through protection fuse, come in 1 wire and another one. Usually, without wiring diagram, from experience, we know these sensors, the 2 wires are the same color at the sensor side that are the heater circuit. In this case, it's black, 2 blacks. So power should come in. If the resistance is good, should come out. And the computer is watching that one here. If it doesn't see that one, it gives us a circuit code for voltage. But right here, it says heater malfunction. It does not say circuit code. Inside here is the transistor, and the computer is applying ground if all the criteria is being met. So here is telling us general description about the system. Okay, you can read that one, pause it, whatever. But I'm interested on this portion. Continuous, sequence, none, duration 5 seconds or more. So if the problem lasts more than 5 seconds, it will turn on the light. That's what we have here. Enable condition. Minimum temperature. So we have to start at least 41 degrees. So that way it can come on. Battery battery voltage between, okay, it's important, state of the engine running, no active DTC for engine cooling temperature. Be careful with those, okay, during secondary here operations when it's testing it. But we have this one here, malfunction threshold. That one is pretty interesting. Okay, this is interesting because it is telling us the computer is watching inside amps, 100 milliamps to 300 milliamps or less. So that is when it will set, or 3.6 amps up to 3.4. So that one is excessive amperage. This one is not enough amperage. Condition 1, condition 2. So we have to check on Ohm's law to make and check the resistance. Okay. What else we have here? Condition for clearing the DTC. The malfunction does not reoccur during 3 consecutive trips. So that is why we substitute the sensor, the heater portion. Okay, let me see what else we have here. So this is the flow chart. I was not using this flow chart, but there is the flow chart there. I did not use that one. But for people that does not have the knowledge or familiar with this, it's needed. Oh, we got the resistance here, the values for the resistance, I believe. Like, where is it? Where are those? I wanted to see how much is the resistance of this. I don't see it. Probably it's me. Where is it? So this is giving me watts. Disconnect the series at the sensor. Measure the resistance between 3 and 4. Is there about 3.3 watts? That's weird. Why watts? That should be ohms. And 3.3 ohms is too much. So this system shouldn't have more than 2 ohms, I think. This is wrong information from the manufacturer. Wrong information there. Check voltage. That's what we did. Okay, so this is the flow chart. Oh, there is a very time consuming. So we were using just the techniques we have learned over the years and applying them. Just look at this flow chart. How many pages we have? 4 pages. And besides giving us wrong information here from people who is following this without experience, right here, ohms. But I don't believe myself this is a right specification. That one, because it's showing us here we have to check in between pin 3 and 4, and it is saying it has to be a room temperature and 3.3 watts. Wrong information. Okay, keep in mind that. Well, we have here the old O2 sensor, which is the denso, the faulty sensor. And as we can see here, this one has two black wires here for the heater portion, and this is the sensor portion, blue and white. So I believe they might be, well, they got numbers sometime upside. I don't see it on this one, but sometimes they have the numbers here on the corner. Okay, this is the resistance, 2000, 259, 260 pretty much. So 2.2 kilos, 2000, 2559. Okay, so that's a lot of resistance. Normally they go open, they do not go with a lot of resistance, but we're gonna compare it to the new one here, which is Bosch. Look at this one. The Bosch has, for the heater portion, two white. That's gonna be the heater, the one are the same color. And we have here black and gray. Let me connect to this one. I'm gonna find out the differences in resistance. Okay, we have here connected the new sensor. It's about 4 ohms, pretty much 3.8 ohms. As I mentioned, that one, we are connected to the two wires, the white wires, heater portion, and this is a non-good O2 sensor. So we can compare that one and find out if we do our Ohm's law and we do the math. Take about 12 volts divided by 4 ohms, it's going to be about 3 amps. Okay, the higher the resistance, the less current draw. Okay, so we confirm that one now. Okay, so we're done now. We found a problem, so now I just will reinstall the new sensor and we should be done. Thanks for watching, and we'll see you in the next diagnostic or repair video. Thanks for watching.